Hello friends, so in today's question, a board of mass 11 kg is placed on the floor and a man of mass 70 kg is standing on the board as shown in case 1. The coefficient of friction between the board and the floor is 0.25. The maximum force that the man can exert on the rope so that the board does not slip on the floor is. So we have to find out the maximum force which the man is going to exert on the rope so that there is no slipping between the board and the floor. And in this case here mu is given as 0.25. So let's draw the free body diagram for the man as well as the board. So we have, this is the man and the board, and the force with which the man will be pulling the rope will be equal to the amount of the tension. Okay, so we are going to find out the maximum value of the tension, and that will be equivalent to the maximum value of the force. Okay. So let us assume T is the tension. So here it will be 2T then, and the man is pulling the rope, so this will be also T, and because of the friction, let us call that as Fr, and there will be a normal N, and in the downward direction we are going to have small m, that is the mass of the board, and plus capital M multiplied by G. And we assume that both man and the board are moving together. So we are going to take man as board as one system. Taking man and the board as one system. So let's find out the various equations. So first equation in the horizontal direction will be 2T is equal to Fr. Okay, you can say for horizontal direction we have Fr is equal to 2T. Okay, let us call this as equation number 1. And in the vertical direction we have two forces in the upward direction, that is normal and T, and opposite to it we have the M plus capital M multiplied by G. Okay. We can say that T plus N is equal to M plus capital M multiplied by G. So from here we can find out the value of N, that is normal. You can say that N is equal to M plus capital M G minus T. Let us call this equation number 2. Now it is said that the maximum force that a man exerts so that the board does not slip on the floor. Okay, you can say that for board not to be slipping on the floor, Fr should be static. Fr should be static frictional force. So we can write the equation that Fr is less than or equal to mu multiplied by normal n. So we already know the equation for Fr as well as n. Okay. So we can write that using equation 1 and 2. Using equation 1 and 2, we get Fr is 2t less than equal to mu, and normal is given as m plus capital M multiplied by g minus t. So we open the right side, we get this as 2t less than equal to mu m plus capital M g minus mu t. Combining the like terms, taking t as common, so we get 2 plus mu is less than equal to mu m plus capital M multiplied by g. So from here we can say that t is less than equal to mu m plus capital M g divided by 2 plus mu. Now it is said that the force should be maximum, so you can write for the applied force to be maximum, tension T should also be maximum. You can say that F max, let us call this as F max and this is T max. So F max will be equal to T max, which is equal to mu m plus capital M multiplied by g divided by 2 plus mu. We substitute the values. So mu is given as 0.25, so we have 0.25 and this is 70 plus 11 multiplied by 10 divided by 2 plus 0.25, and this will be giving us as F max is equal to coming as 90 Newton. So we can say that this is the maximum force, applied force rather, this is the maximum exerted force by the man on the rope so that board does not slip on the floor. Board does not slip on the floor. Okay. So this completes the question. Thank you.